I kind of talk about. I want to hear about because you were that 1% kid or the
Yeah.
0.1% kid or something. I mean, you
Okay. Yeah, yeah. Let's talk about that.
you at some point you took it upon yourself to go through like some significant portion of the MIT's open courseware, OCW. And they posted what that is they for a bunch of their classes, they posted the lecture notes, problem sets, answers to problem sets, midterms and finals, and videos for a bunch of the classes. You're totally on your own, but if you wanted to, you could kind of, in theory, do this stuff. Now, it wasn't for every class, and the quality of the materials, I think, for some of the classes were much better than others. But there was a lot of stuff posted. So, why don't you give a little overview of what that is,
Yeah.
how you get started, and what that looked like? Because that was really impressive that you did that, and it'd be
Yeah,
interesting
sure.
story to hear.
So, yeah, how did this start? Well, um, it started my sophomore year of high school. Um, the or yeah, the summer of my sophomore year in high school. So I'd always kind of been like into math. I liked math, and like in middle school I did like math counts or whatever, but I didn't really take it seriously. Like I
You were
was
like 2 years ahead in math, right?
yeah,
Like
I was
a,
on like the standard, the most advanced track that's like an actual track.
geometry
um,
in eighth grade, I think you said,
yeah,
right?
yeah, geometry in eighth grade, algebra two in ninth grade, um, and well, the school made me take geometry again in tenth grade, even though I had already taken it, and I had to do like a crap ton of lobbying to get into pre-calculus.
Oh,
Um,
jeez.
I can well just briefly what ended up happening. Like I had to like basically say like come on, guy, I've already taken geometry.
Hmm.
Why do I need to take it again? Okay, fine, I'll take it again, but can you let me take pre-calculus? And then so the the instructor actually or one of the head of the math department. I was talking with him about it, and he gave me his notes for the class on or it was like trigonometry or something. Like it was like trig and pre-calc combined or whatever. It was some integrated course, but um, I thought he was giving this to me as like here's what you need to spin up on for a pre-calculus, like let's talk more after you look at this. And so what I did is I solved as many problems as I could in there over the span of like 2 days. Um, and so I got like there's this booklet of like 100 pages, big workbook. I got maybe to like page 50 or something, page 60, and like each page has like a bunch of problems. So probably did maybe on on the order of like 300, 400 problems over these 2 days. Yeah, I went like completely. I was taking this packet around with me to every single class and just doing it in class instead of whatever subject because
Sit in
I'm
health
like
class and music
yeah,
class.
exactly,
You're like,
exactly. And so I
man.
learned he actually tracked me down at my last period class on the second day that I had
Like,
this
hey, kid, where are
booklet.
my notes?
Yeah, exactly. So I didn't realize, but this was his one copy of class notes, and he was trying to teach class with it. And he was like, "Where are the notes?" I thought, "Oh wait, I gave them to Justin. Why didn't Justin give me back the notes?" So he was so confused. And so the problem was like, I had written in pencil all over these notes. He's supposed to make photocopies of this for like for the kids to do for their homework. I don't know what he did the previous day.
Oh,
Maybe he was just like, "Ah, oh,
wow.
crap, I don't know where they are. I guess no homework today." But like, but yeah, so he got it back. He had to go and erase like all the stuff that I'd written down, and I think through that he realized that I was doing at least most of the problems correctly, and that I didn't just say that I worked through a lot of it, like that I actually like, put the work in, and then I was
Yeah, because he had to
willing
erase
to be
every
done.
one. He's like, damn
Yeah,
it.
yeah, he had to go like erase like 50 pages.
F and Justin?
Yeah, either that or like I don't know if he had some other source where he could reprint it
Damn
out
kid.
again.
Damn
But
kids ruined my life.
yeah, I don't know. But it seemed like he was kind of annoyed initially. But yeah, so then I got into that pre-calc class my sophomore year. After all that, after and keep this is not like I'm me arguing to get a year ahead. This is me saying like I already took geometry in 8th grade.
Mm-hmm.
Do I really have to take it again? And I did have to take it again. They still made me take it again, but at least I got to
You went
take
to a
it more.
parochial, like it was like a Catholic school or something.
Yeah, it was a private school. My parents sent me to I went to public elementary and middle school, but my dad wanted to send me to a good high school, like
Mhm.
a private high school, just
Right.
to for superior quality of education, supposedly.
Right. Taking geometry again in 10th grade.
So what the thing I noticed, I mean, okay, we'll get back to the original question you asked shortly,
Mhm.
but the thing I noticed was, um, so the private school, it actually, if you took the mean student of the local public school versus the private school mean student is going to have better stats on their ACT and
Mhm.
SAT,
Mhm.
whatever.
Mhm.
But the spread of this distribution, um, in the public
Mhm.
school, they have way more kids, and way more kids who are kind of in a more similar situation to me, where they're just like really pressing on, like they're far away, they're outliers. In the private school, there's so few students that these kids look like major outliers. They're like, this isn't even part of the distribution. Like, what do you mean? There's no, this kid doesn't
We can just
exist. I
pretend it
refuse to
doesn't
believe it.
exist. It's an anomaly. It's not
Yeah.
real.
In the public
Eliminate
school, they are, they're still way off on the spectrum, but at least they're part of the long tail.
it. Mhm.
And they know that there are some of these crazy kids
Yeah,
who are
both
just
ends. You had
love
your
this stuff.
super low performers, and then you got super high performers.
Yeah.
And like we got to have like AP classes and things, and we have to have some program where some of these kids can take classes at the local community college or something,
Yeah.
right? If you have, especially if it's a sizable high school of like 1,500, 2,000 kids, there's gonna be some of those kids. Where
Yeah. Yeah,
parochial school, it's like
exactly.
we got 300 kids in the high school or something. It's like, well,
Yeah,
if I,
still a tiny proportion, but there's a large enough absolute number of them that's greater than one that there's actually a little bit more support for them.
yeah.
But oh yeah, it was just kind of funny because like it's like ironically like okay, you pay more to send kid to the private school. The private school has higher average stats. You think it's a better quality of education for an outlier kid. Like it actually is like way worse. It's like the public school. So my yeah,
Well,
it
one
was
thing I
kind
want to say too, some of
of
the private schools around here, I know that like Poly and Western, it's like they're really good schools, but they don't like kids that are too far ahead. They don't want weak students. They want strong students who are in that range, right? So the top, the 1%er, the 0.1%, they just like they can't deal with these kids. It's because it's a headache, right? Headache. Like what do we do with this kid? They took kid to calculus in 10th grade. What are we supposed to do with them in 11th, 12th? It's not like public school. We don't want to send them off. They go take in private school. They don't want feel like you have to go to junior college to take classes because the private school can't handle it, right? They can't facilitate their learning. And how much am I paying you guys? Okay, public school, it's like there's no less ego about it than there is in a private school, right?
mhm.
And so it was just such an interesting thing I'd heard about that they because we'd have math academy kids coming out of 8th grade having taken AP Calculus BC, and some of the parents, like your parents, were like, "Well, I want them to go to its private school. We've been planning them to go in private school their entire childhood." It was like, and even if with math cat, be like, "Oh, we really like math cat has been amazing," and yeah, I think it's still disappointing that they can't continue in the high school program, but we want them to go to Poly or Westwood or Sequoia or one of these, expensive, very selective private schools. But then the school's like, what are we supposed to do with this kid? This is the
Mhm.
headache, right? This is a major headache. Okay, 1 year ahead, definitely. We have kids 1 year. 2 years ahead, fine, maybe we'll do that. because then they can take a, but they don't want to do it. It's just a headache. They don't want to deal with it. It's just, they don't want to deal with it. And so they won't, they just sort of turn those kids down. Anyway,
Yeah,
so
exactly.
continue our story, please. Cause that was,
Yeah. So, okay. So took pre-calc and geometry sophomore year. After that, next course is going to be calculus.
mhm.
And so this was kind of getting into the point of like, I'd always kind of been interested in physics and black holes and stuff, astrophysics. Kind of makes for cool visualizations. You watch
Right.
the History Channel documentary on it, you're just like thinking about space and stuff. And I knew that calculus is, I mean, I didn't understand calculus at that point, but I knew that like I knew enough around the subject to know
Enough
that it
there's big
underpinned.
S's, there's dy,
So,
dx's to know that stuff is important.
yeah, because you see that all the time in physics books and whatever, and then like all these History Channel documentaries on physics. It's like when they're just showing like math equations, just like for
Mhm.
effect. There's always a bunch of these big S's, like the dy, dx, like whatever. What is that? Well, whatever this calculus thing is, it. I guess it must be important. And so I just decided that summer that I was going to try to learn it on my own,
Mhm.
because it just got so, it was just cool. It had the cool factor, and like it was also the thing, and we were like, in every movie where like you. When you hear that some movie character is a genius, the way that they often communicate it is that like so and so took calculus, like knows advanced calculus, or what, like from the public perception, calculus is synonymous with super advanced math. And so I was like, okay, this is really cool. I can't believe I'm already here. I'm going to try to just teach myself over the summer because I just can't wait. And so that's how I got into like these online learning resources.
Mhm.
And so I guess I'd kind of started to get an inkling of this back when I was solving those trig problems, getting through a high
Mhm.
volume in one day.
Mhm.
But self study turned out to be so much more efficient than I was used to at school, and it was just like I thought it was going to take me the whole summer to learn calculus. It took maybe a month, um,
Well, that's
and
super fast.
yeah. Well, I was, I mean, once I got
Well,
to like,
you already demonstrated they do 300 or 400 problems in 2 days.
yeah,
So, okay, if you're doing it that rate, that's like, I'm doing 300, 400 XP a day. It's like, okay, or more.
Yeah,
I'm doing 500
exactly.
XP a day. Like, wow.
I was holed up in my room, like, and especially once I got to like optimization and related rates and like basic differential equations and stuff, like I was just it was more than just like this is like cool from public perception, but like this is just like so interesting to me because it was I guess it was like it felt like my first experience of being able to use math as a weapon to open up just a can of
Like a
whoop
power
ass on
tool. It's like a
whatever
power
modeling
tool.
problem I
Yeah.
want to. It's like suddenly I got this like this Jedi lightsaber. I'm just like swinging it around, destroying all these modeling problems.
Yeah.
Yeah, exactly. And so yeah, I just like holed up in my room, just working out math problems. It was like it was almost like playing a video game. Except see the thing is like I was also kind of big into video games in middle school and early on in high school. And I mean my parents never thought that was like, I mean they were fine with it, but they were like whenever I would be playing for like too long, they'd just be like why don't you like go outside or like just do something productive. um but with math, with the calculus stuff, it felt like playing a video game. Except the longer I played, the more proud my parents were of me for working so hard. So it's like
Mhm.
I got unlimited video game hours by doing this math.
What is your mom? So your mom, she went to art school.
Yeah.
So she's like, what are you doing? And what is what
Oh
was her
well,
reaction?
I mean, my parents didn't
Remember?
really. Actually, they didn't ask me a whole lot about it, at least that I can remember. They were just like, "Oh yeah, Justin's prepping for the next school year. Like, good for
Kids
him. I'm
do that
glad
all
he's
the
like
time,
taking
right?
his academics seriously." Like, I mean, they
That's
knew I
funny.
was into like they know I was a serious student and everything, getting straight A's and everything. But it I think it took some time for them to understand the caliber of what I was doing
Mhm.
there. It's almost like they think the kids playing with like a some kind of some simple chemistry set, like let's let's make
Make a dye, make a color.
yeah, make a die or whatever, and actually the kid is building fireworks or something. It was just
Right.
so uh order of magnitude different. So anyway, yeah, so I was holed up in my room, and so after calculus, I finished calculus in like 4 weeks or something like that, and I was like, wow,
That was
it's
hard.
still summer. It's like I still have lots of time. So I was, and also this whole thing, this whole experience was just so mind blowing to me because it was like I didn't understand how slowly we were moving at school. I mean, I knew we could be moving faster by doing more work, but I didn't understand until that point just the level of inefficiency that is happening at school. Like I was always blowing through the homework really fast, um, in class, and mostly just sitting around being like called up to the board to work problems for the class. And it was just,
Mhm.
I mean, on one hand, it was kind of fun being. I mean, I kind of got a reputation for being a freshman who is like showing up all these the smartest junior in
Right.
like in whatever algebra 2 class. But it was also just I was not working at the forefront of my ability. And so yeah, so I don't realize how fast I could have been moving. So
Quick
so
question. Quick
yeah.
question. What materials or book were you using to teach yourself calculus?
So actually the single variable calculus course, um it was not on MIT OpenCourseWare. Everything else was on MIT OpenCourseWare, but the very first calculus course that I took, I it was some like kind of it doesn't exist anymore as far as I know. I can't even remember the name of it. I tried to look it up like a year or two ago. I spent like hours trying to Google for it, just see if I could just uncover what it was. But I can kind of describe it a little bit. It was almost like a textbook, but it was arranged in slides of information. Like you read a slide, you have like 10 practice problems, and you solve those 10 practice problems, and then it checks it checks each problem for you, and says whether you did it correctly. There's not a
It was
whole
the
lot of
Math
explanation.
Academy before Math Academy.
Yeah, it was so weird. It was
What the
like it
hell?
was it was
That's the first time I've heard this story. That's
yeah.
crazy. So a couple slides, they do 10 problems. They check what? The other thing
It
it didn't
wasn't
do is say,
adaptive.
well, you got it, so you can skip these problems and move on. But that's crazy.
Yeah. So it wasn't adaptive. It didn't force you to do the problems. You
Mhm.
could click ahead,
Right.
and if you got the problems wrong, like whatever, it was just like it really was just a textbook, just like kind of cut up into like problems interspersed. And there were some
Yeah.
videos
Proto
and
Math
whatever.
Academy, right? Proto Math Academy, right? Real
Yeah,
basic.
something like that. And it's so weird because I this thing doesn't exist anymore. I don't know what it was, but I can't find it anywhere.
Well, you know what you could do
Um,
is you could go on the web archive to the year that you did this and search for a name, and maybe it'll show up on the web archive.
See, I don't even remember the name of it though. That's the
Okay.
problem. Like I didn't at the time I didn't know that this was going to be like such a big deal. So I didn't bother like writing down
Mm,
like any of
yeah.
this. It's just like a fuzzy memory from like a decade
Yeah.
ago. Um I don't know, but yeah, I'll try and see if I can dig up any other information. But they
Yeah, it
had
would be
something like
interesting. It would be interesting for you to do a little bit of archaeology on this and say this was my sort of proto math academy.
yeah,
This is what it did for me, and you could kind of and then kind of have some screenshots of it, right? There'd be people would probably find that pretty cool.
yeah.
If you could. I don't know. Like I said,
Yeah,
it
yeah,
might be
yeah. I mean, yeah, I'll try. Well, let me just say everything off the top of my head
Mhm.
that I remember about it. Just just in case anyone else knows what I'm talking about, and also just so that I can take this transcript and feed it into an LLM to just see if it knows anything. But like,
Mhm.
so it didn't have any other advanced math. It didn't. I don't even think it. I don't recall it having any simpler math either. I think it was just for like AP classes. Because
Mhm.
I remember I mean, at this point, I when I was initially the first couple of weeks, in addition to studying calculus beforehand, I was also just trying to like, I was also partially just trying to get a leg up on the upcoming school year and learn AP US history beforehand
Mhm.
and stuff like that. So I know they had an AP US history course as well on there, and again, by course I don't mean it was interactive or
Yeah, it was just the
or
slide.
anything,
Well,
but
okay, was it
the
AP
slide.
calculus or just like calculus, calc one or
No, it was
introduction?
AP. It was AP calculus.
AB or BC?
BC.
Okay, so AP
Um,
calculus BC, right? Okay, so it says AP
yeah,
calculus courses.
yeah, and an AP US history. This is kind of coming back to me now. It's like this is funny. It's like recovering a memory. Yeah, I didn't even realize that this was so similar to Math Academy. I kind of forgotten even that I did this sort of thing before MIT OpenCourseWare. Um, okay,
We
what?
could give you like regression hypnosis or something
Yeah,
to like
yeah,
hypnotize you on the podcast.
yeah. That's what we need.
Okay.
Yeah, there were also. I know there were some other courses. I can't remember what they. Okay. I think they may have had like a AP World History as well. I don't think they had an AP Physics because if they did have that, I'm pretty sure I would have been interested in that
Okay.
as well. Um,
Was it like a school or like a that was hosting it, or was it like a something else?
I I don't know. I don't think so, but I could be wrong. I don't think it was on a school webpage
Can
or
you think of
anything.
what the name of it might have been? What's name pops in your head, or the URL, the name of it? Can you?
Um,
I'm hypnotizing you. What do you see, Justin, in your head? Close your eyes. What are you seeing in that
yeah,
address
the name.
bar?
I don't think I'm going to be able to
Look
recover the
harder,
name.
Justin. What are
Just
you
don't
seeing?
know. But okay, the format was like it was like this. It was not a standard web page. It was almost like a square box sort of, and the even the text and stuff in the box. It was not like I don't think it was like copy and pasteable. It's like it wasn't like part of the HTML. It was like some other like it was some widget in there.
Like Java.
Yeah,
Like was
something
it
like
Java
that.
or like or it could have been like it could have been like I think a Macromedia or Adobe had like a courseware thing. They could have used like Adobe or Macromedia's courseware to create it, something like
Yeah,
that.
yeah, probably
Or like
something
a
like that.
FileMaker Pro, something they exported it online or something like that. It's old '90s
I think
software.
there were quite a few videos. Um,
I'll bet you
yeah,
I could be wrong, but I'll bet you it was something like it was either Adobe or Macromedia or something had something called courseware. I think it was the name of the product. I don't know if it's still around. And it would allow you to probably organize and structure, which is probably why it was structured in slides and problems and videos, right?
yeah,
So you could just go in and be like, all right, create a module, okay? And somebody was
yeah,
cutting and pasting from their notes or from textbooks and some videos, and they put together this thing. So anyway,
yeah. That's
okay,
probably what it was.
well, maybe you'll come to something.
Yeah,
Later. But let's go into the open courseware real quick.
yeah. Okay, so after calculus, single variable calculus, then I just like okay, I was just so hooked on this because I mean there was all these things that was like it almost felt like you know in the Harry Potter where like Harry learns that he's like a wizard or something and like,
Mhm.
that there's this whole Hogwarts school and everything and
Right.
it's just so
That was your
like
moment.
there was there was some pieces of like weird shit that had happened to him in the past where it was like he had like talked to a snake or whatever, and he was like not even sure if that was real, but there were some indications, but then all of a sudden it came to a head, and then he's like holy shit, like the glass just shattered. um so this was kind of what I was experiencing at that point. I'm like, holy shit, I can learn way faster than I can just sitting in class in school. I can do it myself. I can do it with online resources, or just even probably just books would have worked, because that's basically what the online resources were. They were just like books with videos essentially. um, and and it was also just like really cool. It was almost like I found a new video game. Calculus, it just felt like a video game. It was the best video game that I had ever played because, like, just there's like infinite, like this climbing up this math ladder. There's just like infinite progression. There's no beating the game and having to go onto a new one.
The infinite game of math.
It's
Yeah.
the infinite game, and you know, like everything that you do in this game, you can take with you later in life. This is a game that actually matters, and it's a game that your parents are actually really like they're proud of you for spending 8 hours just holed up in your room playing this
You're
game.
playing 8 hours playing EVE Online or EverQuest or World of
Yeah,
Warcraft.
yeah,
Like,
exactly.
what are you doing? Like, well, I'm in my guild, and they're like, "What? Get outside! This is
Yeah,
terrible."
yeah, exactly. And everybody's super impressed when you come out and you're like, wow, like my kid taught himself calculus over the summer, and like it's just it's so funny how similar it is to just like my kids spent the summer playing 8 hours a day of Call of Duty, and
Like,
achieved,
you're not
like,
telling people that unless you're just complaining. Like, my kid only plays Call of Duty. I don't know. I'm worried
yeah,
he's
yeah,
going to be
exactly.
deranged. What do we do about this? Is the
Yeah,
opposite.
yeah, right. It's seen as a problem, but you just change it to like calculus or math, and suddenly it's like the perception just does a complete 180, but the experience is the basically the same.
Yeah,
So
you were
yeah,
having
so
more
okay,
fun. It
so
was
I
more
was hooked
fun.
on this. I'm like,
It was more
I,
fun than playing Call of Duty or EVE
yeah,
Online.
yeah. So I beat the calculus game basically, and I'm like, okay, what are we doing next? Like I'm like full on addicted at this point. I'm just like I can't make it through the summer without more math. Like, what am I gonna do? Like not do math the rest of summer? Like that sounds terrible. So I'm like,
What am I
okay,
going to go to a pool and swim with my friends? I'm not going to do
yeah,
that.
yeah,
That's terrible.
yeah, exactly. It's like can't even bring scratch paper there. I'll just get wet.
Yeah.
But, yeah. So I that's when I went to MIT OpenCourseWare, because I was like, okay, well, I know after this is university level math. Where do I learn university level math? And it was like, so part of the reason that I went to MIT OpenCourseWare is it was not just because it had these courses on it, but it also had a clear like progression. I'm like, okay, this is a 100 level course. This is a 200 level course. This course has those courses as prerequisites. So it was like I could get a sense of the skill tree. So I found out that linear algebra and multivariable calculus are the two courses that you take after single variable calculus. So I just went on and started with those, and I actually got through like most most of them during the rest of summer. And once school started up again in the fall, I was just like, I was not about to just stop this and go back to just normal going to class, sitting there
Yeah.
while the teacher waits. I'm like, screw this. I'm doing self-study in school. My school hours, I'm gonna be self-studying as much as I can. I'm gonna print out materials. I'm gonna sneak an iPad into class if I need to. I actually did that for 1 year. This was like a no technology allowed in class. You get a detention for bringing a phone or something.
You're going to detention for teaching yourself linear algebra. That would be a first.
Yeah. So eventually, yeah, this was a little later on once I realized how much I could get away with as the smart kid in school.
All
Like,
right. The teacher's not worth her trouble. It's like, Justin, What are you doing with that? They just whatever.
Yeah. And so I would also like, I wouldn't be like obviously out with it. I would like have my stack of books arranged, have a little paper covering it. Like
It was kind of
I
a
was
don't ask, don't tell
exactly, don't ask, don't
self
tell. And so the
education
teachers would
program.
get like a suspicion, like, okay, Justin is never looking up. He's always like writing something or looking like he's reading something. But the thing is, I would also, I would keep a general sense of what's going on in class. Um, so I would like because I knew if the teacher calls on me and I'm just like, what are we talking about? They're going to be like, okay, Justin, what are you doing? But if I can actually respond like with a decent answer to whatever question they have, it doesn't have to be my highest effort best answer, but it has to be just something that's like, okay, kids paying attention, even though they don't look like it. Then I can continue
Because you
doing what
always
I'm
have those
doing.
kids that are to doodle and draw,
Mhm.
and teachers like whatever, you know.
Yeah. Yeah, yeah, exactly. So I would kind of kind of keep an ear out for like anytime the teacher is asking questions or anytime there's a risk of me being called on, and just make sure I'm kind of prepared for that. But other than that, all the other time I'm just I've got my educational resources, my papers that I printed out, or my iPad for reading this PDF
Mhm.
of a book, and and so I'm just going through doing this thing, like 8 hours a day at school. Probably 6 of those 8 hours were dedicated to this math self study every single day. And
Wow,
yeah,
that's
so
a lot.
I got through linear algebra, multivariable calculus. Um, I got through like the first semester of physics, like calculus based physics, mechanics. I got through like I think like half of electricity or most of electricity and magnetism. It was more than half, maybe like three quarters. I got through like basically up until however much you need to know for like the AP exam, which was not like the full MIT course,
Yeah.
but it was most of it. Um, and also did differential equations. Um, I think like maybe 2/3 of that, and maybe half of real analysis. And I also got an abstract algebra book, and I did group theory. I didn't go on to like ring theory and field theory, but I did group theory.
But that
Oh,
was
I
not
also
open
did
course. But that
probability
was
and
not open
statistics.
courseware.
Sorry.
That was not open courseware. The group, the abstract algebra you said you got, that was the one you got a book for.
Yeah. Well, okay. So at some point it kind of turned into the open courseware courses were really they were pretty solidly built out for like linear algebra and multivariable calculus.
The
There
sophomore
were
level
plenty of
stuff, right?
problems and
Yeah.
videos.
Yeah.
And for the freshman physics, and yeah, the physics open courseware course is the one with Professor Walter Lewin. He's like that famous. Do you know that guy?
I don't.
He's got all
Yeah.
these like cool physics demonstrations that he does.
Oh, yeah, he's famous for that, right? Yeah, okay, I know
Yeah,
that
yeah.
guy.
He would like his thing was like he would always like put his life on the line for physics. He would do a, like, pendulum experiment where he has some big pendulum with a big like bowling ball on it, and he's gonna take it to one side of the room, let it go, and it's gonna swing back at him after it completes a cycle, and he's not gonna flinch. He's just gonna stay there, and it's gonna come within like a centimeter of smashing his face in. And
Mhm.
yeah, so he would do all those things, and anyway, so that was like on the right. That was like on the. I would watch the lectures for these and do the problems. But for the higher level courses beyond that, it just got like thinner and thinner. Like you get to an abstract algebra course or real analysis course, and it's like basically what they have on open course, or at the time, I think it's built out more now, but at the time when I was using it, like 2012 or whatever, was it would just list the textbook that they use, and maybe have a copy of some
Syllabus.
midterm and a final, or a couple problem sets if you're lucky, or something like
Yeah,
that, or
yeah.
some like scratched lecture notes or whatever. But it got to a point where I was like, okay, I don't really use MIT OpenCourseWare anymore. I just use it to point me to what courses are realistic to take next and what are the books that they use, and then I go directly to the
What are the
books.
expectations? Like, what are you supposed to learn out of what's covered, essentially? Yeah.
Yeah, yeah. So I actually printed out um, yeah a Tom Apostle analysis book,
Yeah,
and
possible.
I forget what it might just be called analysis. I can't remember the name of it, but it was
He's
Apostle.
a Caltech
Um,
professor, right?
yeah, and and so I would take that with me to school then. Yeah, and I just work through.
What abstract algebra book did you use? Do you remember? Who was the author?
Uh, yeah, I don't remember.
Okay.
I'd have to look that up. I would probably know it if I saw it, if I went through like some of the common ones, but I don't know off the
Um,
top of my head.
right.
But
Like
I should say one
Hurston,
thing I
Fraley, and Gilleen or something. And I remember the honors one we did, which was, well, let's see, there was, well, we did Hungerford, which was the graduate text and mathematics, which was just
yeah
brutal for a first year abstract algebra course. I probably didn't use that one, but yeah, okay.
yeah
So go on. So you were
well
using
I
books at that point, yeah.
yeah I was using books, but I like in hindsight I did make the mistake that pretty much every ambitious math learner makes, which is to go to materials that are just too advanced. And so like Apostle, I mean that was like the honors calculus at MIT, or not, sorry, not calculus, honors analysis at MIT, and and so it's just very dry and abstract, and so
Theorem
through
proof,
that,
theorem proof, theorem
yeah,
proof.
theorem proof.
No
No,
discussion,
I
no real, very little motivation, context. You know, really discussion about what are we really doing here, how to really think about this stuff, how to frame it, and it's just,
yeah,
yeah,
and a lack of concrete examples in particular. Like
terrible.
I didn't realize that at the time, but like how you're supposed to think about it, like as like here's a theorem. Let me think of some concrete examples of it, or like try to come up with counter examples, and or you know that kind of thing. So I was, but so what ended up working out okay was I got really solid on a lot of the proofwriting mechanics of it, but so I got really good at pushing the symbols around in logically consistent manner, but
Yeah,
I didn't really have a great feeling for analysis. I mean,
sounds like
I could do
most
epsilon delta
most
proofs.
sounds like most undergraduate math majors,
Yeah,
right?
yeah,
We're playing this little game of pushing symbols around, but nobody really has a great intuitive grasp of the subject itself because it's not really taught. It's not, you're not really structured in that way. It's, I mean, it's fine if you, I mean, I could see how we're going to push symbols around until you get fluent in this, and then we're going to talk about things
hmm
at a more structured, intuitive level. Although I think pushing symbols around without concrete examples is just a really inefficient way to go about things. But they just
it
skip the
is.
concrete examples and they never get to the let's talk bigger picture here. What is real analysis about? What are we trying to achieve? How to think about this subject? How does this fit into the framework of upper mathematics, into the profession of a mathematician's profession? And you never get to any of that. And so you just do the theorem proof theorem, and then it's so
Yeah,
poorly done at the undergraduate level, almost without exception. There are probably a few, probably like 2% of professors, math professors at the university level, undergraduate university level, who take it really, who take the pedagogy seriously and are really trying to teach them. The rest just show up, lecture, problem set, whatever. Good luck.
yeah. So I fell into this trap, and yeah, it was in hindsight, it was yeah, it was very inefficient to be working this way because I basically was picking up on what most math undergrads pick up on is like, okay, this is how you do proofs. This is general logical reasoning patterns, but what exactly have I proved in real analysis? Like, how does that work again? Like, what is all this like? do I have concrete examples of these theorems, or like, do I feel it in my bones? Not really, no. um, so this took me a while to realize, but I but that was the situation at the time. But yeah, so after I did, well, okay, that was my junior year of high school, when I was just like going crazy doing all this math stuff. And my junior year of high school, I also, well, I should say, I also did a like introduction to Python course on MIT OpenCourseware. So that it wasn't like super intense. I didn't follow it up with more computer science courses, but that at least got me to the point where I could write some simple like play scripts to compute this or that, or run a simulation of something cool.
Right.
And so my junior year, then the one thing that my high school did have going for it academically was it had this research program, which would it was a research class. It was almost like the chemistry and biology AP chemistry and biology teacher. They were friends, and they had it was kind of a similar thing to I think that a smaller scale of like what you and Sandy did for Math Academy, where it's like you just like your own sheer force of will just rammed this thing through, made it a thing, and now it's a thing. And so they had done that at like decade ago or something. It was a long standing thing. And so they had this research class, and they had some relationships with professors in the area where they could they would you signed up for the research class, and what you were expected to do is you would cold email professors that you were interested in doing research projects with,
Right.
and they would coach you on how to email a professor, how to like who to. They would kind of coach you through the process, but you had to go out and do it, and you had to go. It was the last period of the day, so you would go and meet with the professors in person. You would leave the school. You were allowed to do that as part of this class, and so the goal was to get a kind of like year-long research project that you would do in some professor's lab that you would then present at science fairs. And so I did that, and I ended up working at IU South Bend in Professor Elon Levine's lab. He does
IU is
dark matter.
Indiana University.
Yeah, Indiana University in South Bend. Yeah, and yeah, so he did dark matter research, and in particular, it was an experimental physics lab. So they had these they worked with the COO project, which is in Fermilab. And so what they would do in their lab was that they would supply these sound detectors, and so these sound detectors would be attached onto and to the sides of this bubble chamber that was filled with a superheated liquid, and it was a ways underground. And the idea was like detecting unknown particles whizzing through the air by the sound signatures that they make when they whiz through the bubble chamber, hit a molecule of the liquid, and then because the liquid is superheated, even a small collision then causes a bubble, then like expands and erupts, and this creates a sound signature. So now you got all these sound signatures of different particles, and it's underground to limit the amount of particles that we don't really care about. And so the sound signature would get picked up by these acoustic transducers. And so my project had to do with creating a material to improve how much sound passed through, just to improve the resolution of these.
Was any of the math you learned applicable in this case, or the physics itself?
The physics came into play a little bit, but it was mostly it was kind of like materials science, I guess. So the thing was like I was super into like the astrophysics stuff, but it's just like, as a high school student, you get kind of slim pickings
Yeah, beggars
for
can't be choosers, right? I
yeah,
don't want to do
exactly.
dark matter. I want to do,
Yeah, it's like I don't want to do
Vice
experimental
orthogonal.
physics.
Yeah.
I want to do theoretical physics. I want to like, but it's just
Shut up,
like,
kid. This is what you're getting.
yeah, exactly. Right. So it's like okay, I'm doing a dark matter project. It's an experimental physics. I'm not
Yeah.
great with experimental physics. It doesn't leverage all the skills that I've built up, but it's physics. I mean, it's dark matter. I get to write about it, I get to talk about it. And
That's real cool. Yeah.
what ended up coming in useful is like all the physics and math that I've been learning for talking about the subject, about dark matter, and presenting at science fairs and stuff. There's a difference between a kid who just does a project and doesn't really know much about the subject outside of the one project that they just like followed the recipe on,
Right.
versus the kid who has like lots of exposure to physics and math and everything, and so you can just talk more and like impress the judges more, because like at these science fair competitions, what they're looking at is like it's not just your project, it's also your communication of your project and your ability to talk about like just the overall context of the project. Like, convince me you know what you're talking about, and this is not just like that you are begrudgingly going and presenting this at a science fair because your parents made you do this thing.
Yeah. This is which you went to like the National or Westinghouse or some big science
So
fair, right?
yeah, this ended up I ended up taking this project to Intel International Science Fair.
They
And
kind of took over the Westinghouse. Kind of became the Intel for a while, I think.
okay, yeah, now it's the
Westinghouse was the big
Regeneron.
one for a long time, and then they give out scholarships and stuff, and I think Intel basically took it over. I don't
Yeah,
know if they still
yeah,
are or
yeah,
not.
yeah. So that was 20 the spring of 2013. It was the 2012 to 2013 school year. And yeah, so I got to fly out to Arizona, I think it was Phoenix, Arizona, and present that. And that was just um, yeah, it was kind of a wild experience because I mean I just kind of I mean, and now I see like the paths and the pipelines for doing this stuff, and it's like all clear. I have a bird's eye view of how this goes. But at the moment, I was just kind of running in whatever direction felt like I was learning a lot and felt like it'd be good for my future. And yeah, so it was just it was shocking to me how much my life had changed in that year.
Because of doing that
And
math. Did
yeah,
you learn any more math after that, or were you continue, or were you just focusing on the physics research?
so yeah, so actually, I had around that time, I had decided that the next year I wanted to see if I could get some original math research
Mhm.
um, to do as a science project. Because I was still like, okay, do I really want to do experimental physics again? I don't know. I mean, don't get me wrong, like it was fun. I had a good time, but it was like there was like something calling to me over on the math side, the pure math side,
Right.
or at least very intense mathematical modeling, and I wanted to see if I could do that. So the summer, 1 year after I had started this kind of self learning journey, I was like, okay, I'm gonna try take the summer and just come up with original math research
Mhm.
and see if I can roll that into another science fair project. And so what I did was, I mean, okay, it's one of those things where it's like it's a little embarrassing in hindsight because I fell into like the trap that like lots of people fall in is like you make the jump into research too early because you get cocky, you skilled up, you get too big ahead. You're like, oh, I'm like the math genius because in South Bend, Indiana, I was the math genius. Like out of like
Right.
I didn't know just
Yeah.
where the bar is for like I didn't understand that there were other people elsewhere in bigger cities who are doing the same track, and I thought I was just like stand out, and I'm like, okay, well, why don't I try to do math research now. And so I came up with a kind of cool project that was where I one of the things I learned in calculus was about the partial fractions decomposition.
Yeah, I
And
remember you talking about that. Yeah.
yeah, one thing that I kind of liked, one perspective to math that I kind of liked was like just really reining in hardcore computations. And so
Mhm.
I was like, the kind of thought experiment that I was having is like, what if you suppose you have an arbitrary polynomial over an arbitrary polynomial? Can you come up with a formula for the partial fractions decomposition of that?
Mhm.
And
Mhm.
that just seemed like such an interesting thing to try to tackle. And
Mhm.
so I spent the summer trying to tackle that and just running. I took a kind of like almost like an experimental mathematics approach to this,
Mhm.
where I would run simulations of, in Wolfram Alpha, here's a polynomial over a polynomial, and I would get like a table of the partial fractions expansions for like a first degree, second degree, third degree over a first degree, second degree,
Right.
third degree, like these coefficient relationships, whatever, and then try to extract patterns from the table. And that actually went pretty well. And I got some patterns, and I was able to. I think the full case of polynomial over polynomial got way too hairy, but I could do like a x to the a arbitrary power over uh, over a fully factored polynomial,
Mhm.
a product of linear factors,
Right.
and raised to any power. Um,
Mhm.
and and so I came up with a general formula for that, and I proved it using double induction, actually. So
Mm.
I'd never learned about double induction before, but I'd learned single induction in pre-calc class, and my proofwriting chops from working through a lot of this, like MIT open course, like abstract, like proof based, like Tom Apostle analysis. My proofwriting chops were developed enough that double induction was just kind of an obvious consequence. And so so I did that, and yeah, I got a a result there, which was kind of cool. But I later realized, um, I think this was more in the fall of the school year. Like I just been like poking around other math, and I realized like in complex analysis, there's this thing called the residue theorem, which basically it's a more efficient way to compute. Like you can use it to more efficiently compute partial fractions, and it like most things in complex analysis, it just turns out really beautiful.
A
And so
general case for
yeah,
the real analysis.
exactly.
You have this
So
extra
I was like,
dimension, and it makes everything fall right into place.
exactly,
Which is
but
kind of like why physicists are always trying to add these dimensions, because you add these extra dimensions, and then all the really hard stuff in the 3 or 4 dimensions just like falls right out of it. You're like, yeah, it's like magic.
yeah,
If we had this extra
yeah,
dimension,
exactly.
assuming they're real.
Exactly. And so, but the end result was I realized like, wow, this thing that I had done. I mean, it was a cool result for me. It was like, if 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 complex analysis had not been discovered yet, maybe this would have been a cool result. But we're further
Yeah.
along in that,
So
and it's like, what? Well, I guess nobody cares. But so that just turned into basically a rep on research for me.
yeah, it
But it
sounds
was
like it
like,
was a
okay,
good
well,
exercise for you. It sounds like it was a really good.
yeah,
You came up with the
yeah. Oh,
idea,
totally.
you researched it, you characterized it, you used experimental um, methods, you proved result, you saw patterns from the experimental results, characterized those, came up with a way of stating it, proving it. So I mean, that's where you went through all the full, and then discovered that it was actually had been already done elsewhere as a special case of some other thing. So yeah, the
Yeah.
whole experience of a mathematician's research, right?
Yeah, exactly. Yeah. But there's a lot to learn from that. I mean, okay, so that's one of the reasons why I on X, Twitter, I'm often like no, discovery learning, save that until you've got your fundamental skills in place. Um, because like you don't want to, it's just inefficient, and I mean, there's stuff to learn from it, but it's way better if it takes so much time to go through and make a discovery. Like, how about let's save that for when making the discovery actually
Get more out
yields
of it. We want to get
serious
more
results.
out. We can get more from these reps if you have the component skills in
Yeah.
place. I mean, it's like
Yeah.
you right. We're thinking of like what's the most efficient way from go to A to Z, and so if you know the total number of sort of area under the curve, the total hours put in, if you try and do stuff too early, then there's a great inefficiency. It's great. Like you brought some stuff forward that you would have learned later, but in aggregate, you spent more hours getting to Z because you're not getting as much out of it. And you could have spent that time getting these really important requisite skills in place,
Yeah.
you know.
Exactly. And the end result of your even if you manage to make the discovery, like guess what? Nobody gives a shit because it's not real new. It's new knowledge to you. You did research, like relative to your own knowledge base, but humanity has more knowledge. It's not a
It's nothing. Yeah.
publishable result mathematically.
Yeah.
So it's like, yeah, you want to when you're gonna invest a lot of time and effort into a project, like make sure it's something that's actually really really impressive. But so yeah, so what I ended up doing is I ended up doing another experimental physics project because so that same summer that I was doing all this mathematical stuff, I also was doing an internship at Notre Dame's QuarkNet program, and so it was another kind of like let's improve a physics detector. This one was the CMS detector at CERN, and so they were the way the data was transmitted in this detector was optical data. It was flowing through these light guiding plastics, and so the goal it's a similar thing where it's like let's improve the resolution by choosing plastics that that allow the most light to get through, conserve the signal the best, and I got this internship there because I guess in junior year I was just kind of like the standout smart kid at the school, and it's like, well, there was the school had a relationship with this QuarkNet program where it's like every year they send like a kid there, like who's the smartest kid in the grade, they get offered the
Send
QuarkNet
us your
project.
top nerd.
Yeah, Sunday's your top nerd. And so it kind of goes into the effect of pre-learning and the smart kid effect that we've talked about on previous episodes, where it's like, well, I'm in the running for I'm the one who got selected for that, and so I got this opportunity, and so I did that. So the following year I did another science project on this, but yeah, this one didn't make it as it was kind of funny. This one didn't make it as far to internationals, and but the reason that it didn't was there were two things. First was I was doing it with a partner, which I thought would be kind of fun. The teacher of this research program advised me against it because he was like, dude, there's a limited amount of funding to send kids to the International Science Fair. It's not about we can only send this many projects. It's about we can only send this many kids. So if you have two people on a project, then it needs to be
cost,
yeah, twice the cost. It needs to be twice as bad. You need to have more than twice as high likelihood of going to internationals. So and doing well there. So the project was I think it was better than my initial one, but it wasn't like an order of magnitude better. Yeah, which again is I fell into so many of these like junior researcher scientist traps, like the whole like, okay, let's take analysis,
right?
hard analysis, concrete examples. Who cares? We don't do that. We're like
Rookie
we're
rule.
the elite. I only use the elite hard books that don't do concrete examples because like that's what smart kids do, right? And like, oh, let's do mathematical research. Let's not. Nah, we don't have to consult anyone to make sure our problem statement is worth digging into. Let's just dig into it and see where it goes. And then again, like the adult in the room who has like plenty of experience with science fairs is saying like dude, don't bring a partner on this, like.
Right.
And there was no need for me to bring a partner on it. Like it was like there was this other guy who was like working on just a similar vein of the internship, and like at the end I was like, dude, why don't you be my science project partner and we do this just because thought it was fun. But
Mm.
again, not listening to the advice of the person who actually knows what they're talking about. So yeah, the reason why I'm so like learn your fundamentals first, concrete examples, all these things like kind of like that on Twitter and in my writing and everything is because I've fallen into I've hit my head on basically every ledge there is to hit your head on this
Yeah.
kind of thing.
Yeah. Well, I mean, so I think it's hard-won advice. You know, you learn stuff the hard way. You're not just repeating what you heard somewhere else. Like, I can tell you why this isn't going to work or why this is not a good idea. Just like that, I'm sure the professor told you. He's like, money, the constraint of money is really a big one and you need to think about, And so he was trying to tell you, of course, you're like, money, I don't know, adults have money. They have tons of money. Like, no, you understand. So, yeah, I think that's it. But that's why it's so, there are more and less efficient ways to do things. The most important thing is that you do something. You really put your
Mhm.
effort into something. The best is if you kind of listen to some good advice and you can get the most out of it possible. Worst case, it's not as efficient, but you learned a lot. You
Oh
made some
yeah.
mistakes. I mean, it'd been cool if you had gone to the internationals or whatever, maybe that would have been like a more interesting, rewarding experience in total. But you certainly got a lot out of it. If at the very least, not the very least being you got some hard lessons. Like, oh, I'm not doing that again. I'm not doing that again. These are
Yeah.
these are rookie mistakes. That's the thing is like rookies got to make rookie mistakes. And part of
Yeah.
rookie mistakes is they don't listen
Yeah,
to senior people, right? No, it's old people. They don't know stuff, right? I just want to do it. Okay, rookie.
yeah.
See you at the end. I'll see you at the finish line. How'd that go for you? You know what I mean? So,
Yeah. Yeah.
but
Yeah.
that's great.
Exactly. So that's, I mean, this is all one of the reasons why I'm just so intensely motivated to just get all the foundational skill building, everything, get all this pipeline as part of Math Academy, because it's like if you have the right guidance in this, like I saw so many other kids who went so much further, who had put in it's not that they put in more work, but it's that they had better guidance and they were better listening to said guidance.
Yeah.
And they came much further. So yeah,
Yeah.
that's
No,
been one of my core
that's
motivations.
I think that's a really good point. Yeah. It's like really that. Yeah. I get it. So for Math Academy, for kids who go beyond calculus, for the segment that is in high school or whatever, or early college, and they're like, look, I want to just get way ahead and making it very possible to get these like undergraduate level skills on lockdown. It's like math, probability and proofwriting and analysis and linear algebra. Like stuff is just rock solid. Complex variables and stuff. It just makes so many more things possible and open later. But the thing
Yeah.
is, and it's
Yeah.
so the thing is, like, this stuff is a solved problem. Like, we've solved this for the most part. I mean, we still got some more to prove. Not to, no pun intended, on the proof stuff. I think we still have some R&D work and how we're going to really tackle that and how it's really going to be done, in our real analysis and abstract algebra courses. But we can lock this stuff down so that it is just extremely efficient to go whatever level you want up through the undergraduate level. No, there's no rough edges. It's just, and like, and then it allow people to just launch earlier and with more momentum and with more confidence in these various directions, where otherwise they don't even get nearly as far as you did. I mean, you had a lot of perseverance. I think this says a lot about, everything from your aptitude to your work ethic to your ability to self-organize, time manage, that you were able to get through all this stuff on your own. But a lot of kids, it's just not, and most kids just aren't going to be able to push through
Yeah.
that stuff. It's just too difficult. It's too not enough support, not enough structure, not enough of everything,
Yeah, right. Having the path and the direction makes it more accessible to lots of kids who could do it if they focused on it.
Yeah.
Yeah.
We always jokingly refer to it as the cattle chute. Just get them in the cattle chute, right? Just
Mhm.
go, right? Like you don't have to be like, what? Just don't even worry about it. Just go. Trust us. This is the way. We're going to get you to the end as
Yeah.
efficiently as possible. Just, you don't have to be like, well, what about that? Just don't do that. I mean, you can. It's hard. You want to learn some lessons about how to waste time and, not get to where you want. But if you
Yeah.
just get in the system, like, it's pretty straightforward.
Well, we can maybe on a later podcast we can go through part 2, which is like there's there's all of these lessons that I learned in high school. Like this is like this is the first half. There's a whole other half of getting into college, placing into the most advanced math classes, whatever, like that. I know you had like a lot of experiences on that front, and like just getting slammed in the face with like some of the craziest math. Day one abstract algebra. Here's this 20-page packet of definitions or whatever.
50-page packet on
50. Yeah.
Trump definitions and abstract algebra. You're like, Jesus, what is
Yeah.
this?
We should probably save that for
Yeah.
for a future one.